22, part C. It just asked where the graph was greater than 0. So let's take a look at this graph. So greater than 0 means above the x-axis. When you answer, you give me an interval, and you're using the x value. So we see it's only above the axis right here. So that's starting at 0 and ending when x equals 1. They get parentheses because I didn't say equal to. What if I had said, when is f of x less than 0? What would you have to say? We'd have to go negative infinity to negative 3 because I didn't say equal to 0. So we can't include union, negative 3 to 0, union 1 to infinity. No. That's if zeros are where it hits the x-axis. So that's the negative 3, 0, and 1. The inequalities, so greater than or less than, you're always going to give me an interval. Is that one okay? Okay. So, next up, 23b. What should we do first? So multiply to 15 and add to 8 would be x plus 5, x plus 3. If I'm looking at this, can you tell me right now what x cannot be? And why is that? Okay. So now our strategy, since this was an equal to, we just tried to get rid of the fraction. So the first one has an x plus 3 on the bottom, so if I want to get rid of it, I have to multiply by x plus 3. But if you do it to 1, you have to do it to all of them. So these would cancel out, and these cancel out. Alright, this one has an x plus 5. So I have to multiply it by x plus 5, which means everything gets an x plus 5. Those are gone. So we're left with 1 times x plus 5 plus 4 times x plus 3 equals 2. X plus 5 plus 4x plus 12 equals 2. Add like terms. So if we subtract the 17, we get 5x equals negative 15. When you divide by 5, you get negative 3. But we said x can't be negative 3 because we plug it in, it makes the denominator 0. So there is no solution on this. So make sure you're checking your answers on those. 24. The inequalities are different. With the equations, we tried to just multiply to get rid of the fraction. But with an inequality, we can't because we know that if you multiply by a negative, it flips the inequality. And I have no way of knowing if 2x plus 1 is positive or negative. So I wouldn't know if I had to flip my inequality or not. So what we did, our goal was to have a single fraction on one side and 0 on the other. And then we made a sign line. So we had to figure out what makes the top and bottom 0. So x plus 2 equals 0, that gives me a negative 2. 2x plus 1 equals 0, that gives me negative 1/2. Then what did we do? Graph it. Maybe. So if we have it, we had x plus 2 on top, and then 2x plus 1, was it, in the bottom?
Yes.
So if I take a look at this graph, we want to know whether it's positive or negative. So that's above or below the axis. So if I look, before -2, this thing was above the axis, so it was positive. Between -2 and -1/2, it's below, so that's negative. And after 1/2, it's positive again. We wanted everything less than or equal to 0. So less than means the negatives. Equal to means brackets. However, can both of these be a bracket? No, because the bottom of a fraction can't be 0. So the -1/2 has to get a parenthesis. So it's bracket -2 comma -1/2. Is that okay? So if we look at E, it's an inequality, so we need the same setup, but we don't have it to start with. We have a fraction on one side, but I need 0 on the other. So what we do first is subtract over the 2. This is just like a 2 over 1. I need to get these into a single fraction, so we need a common denominator. So I'm going to multiply this by 5 minus 3x on top and bottom. Since this is a subtraction, I'll go ahead and distribute that negative. So I get 6x minus 4 over 5 minus 3x is greater than 0. So now it's like the last problem. We need our sign line, but we need the numbers that make the top and bottom 0. So we get 2/3 and 5/3. You guys okay there? Then what do? Graph it. So we had 6x minus 4 over 5 minus 3x. So if I look at this, before 2/3, my graph is negative. Between 2/3 and 5/3, it is, and then after 5/3, it's negative. I asked for greater than, no equal to, so we want the positives, but we don't have to worry about brackets, so it's just parentheses, 2/3, comma, 5/3.
How did you know? I just so I would know. Between 2/3 and 5/3, how do you know it's positive?
Because it's above the axis.
Okay.
Anything else? Okay. Next question, 25. So let's do a quick recap on asymptotes. You need to know this. So maybe jot it down if you don't remember. They have to be equations. So vertical asymptotes are going to be x equals a number. And that number is what makes the denominator equal 0. Then we have horizontal and oblique. So there's two possibilities for horizontal. You get y equals 0 if the top degree is smaller. Or you'll get y equals some other number if you have the same degree on top and bottom, you need to divide the leading coefficients. Everybody with me there? When do we get an oblique asymptote?
The top of one equation.
Those will be a full line, y equals mx plus b. If the top degree is one bigger, and in that case we divide the leading coefficients. Oh, sorry, we don't divide leading coefficients, we do long division, sorry. I think I was looking at what I wrote from the previous one. Okay, so let's look at 25 now. So our rational function. So vertical asymptote would be what? Vertical, you just look at what makes the bottom 0. All right, what is the degree of the top? Degree of the bottom. So the top is one bigger, which means it will be oblique. To find it, we do long division. So the top goes under here. I'm going to put in a 0x. X minus 2 goes on the outside. Remember, we don't have to do all of the long division. We're trying to get a line. Y equals mx plus b. So we start out, what is x squared divided by x? And then you multiply. X times x is x squared. X times -2 is -2x. What do we do here? Those drop. 0x plus 2x. And this is all we need. What's 2x divided by x? So our oblique is y equals x plus 2. So it will always be a line, which means you'll always only do those first two terms for the long division. Is that okay?
I forgot how do you graph an oblique asymptote?
It's just a normal line, so you start at the y-intercept. So it would be 2. Then your slope is 1, so you go up 1, over 1 from there. Anything else? Let's look at 28. So, finding an inverse. So we had kind of a series of steps we went through. Step 1 was to change f of x to y. So it becomes y equals. What's step 2? So my y becomes an x. Both x's turn into y's.
Solve for y.
So I could multiply over the y minus 1. You get xy minus x. Okay, I need everything with the y on one side. So I could subtract over my 3y. And everything without it on the other. So then I could add this x. We get xy minus 3y equals 2 plus x. Then what?
Take out a y.
And the bottom.
And then step 4 is change y to f inverse of x. So just a notation thing. So the inverse is 2 plus x over x minus 3. Now, domains and ranges. The domain of the original function.
Equals the range of the inverse.
Right. The x's in the original become the y's. So the domain of the original becomes the range. So to go back to the original, it's a fraction, so we know the bottom can't be 0, so x can't be 1. So how do I write my domain? The range of the original is the same as the domain of the inverse. The range in the original, the y's become the x's. So it's easier to find a domain than it is a range, so go to your inverse. What's your domain?